Next, we're going to take a look at the present value of an annuity. But first, let's compare present value versus future value, or the amount of an annuity. An example when you would use the present value of an annuity would be when you borrow money for a car. Versus future value, or the amount of an annuity, in which you would be saving money to buy a car. So again, present value, you're going to borrow money, so you have an initial amount of money, and then you're going to slowly pay off that loan with interest. Versus future value, you put money into an account until you reach your goal. So notice from my diagrams, let's say the car costs $20,000, or that's the loan that I need. I'm going to slowly pay it off for several months or years until I reach zero. Versus future value, I'm starting with zero, I'm slowly putting in money until I reach my goal of $20,000. Also recall from our last lesson that the amount of annuity was equal to R1 plus I to the n minus 1 all over I, and that this calculation would be all your regular payments that you put into your account plus interest. So the present value of annuity is the principal that must be invested today to provide the regular payments of an annuity. So this means you start off with some money, either a loan or an account that you've saved some money in, and then you slowly pay off that loan or withdraw the money from the account at regular intervals until you reach $0. Notice the formula for the present value of annuity is R times 1 minus 1 plus I to the negative n, all divided by 1. In this formula, you see that the exponent is negative, because remember that present value is the amount of money that you borrowed or started with, so it's got to take off all the interest, so that's what the negative n does. PV represents the present value of the annuity, R represents the regular payment for that loan, or how much money you withdrew from an account on a regular basis. I represents the interest rate per compounding period, and N represents the number of compounding periods. So let's go through a few examples. So example 1, Nick wants to withdraw $400 at the end of each week for 20 years, starting 1 week from now. He can earn 4.16% per year compounded weekly. How much does Nick need to achieve his goal? So first of all, let's start with our formula. PV equals R1 minus 1 plus I to the negative n all over I. So what values do we have? We don't know the present value, but we know our regular payment is $400. We know our interest rate is 0.0416, and since it's weekly, we're going to divide it by 52. So that gives us 0.0008 for our weekly interest rate. And N is going to equal 20 times 52, so 20 years times 52 weeks per year. And that gives us 1,040 weeks. So next step is to sub these values into our formula. So we have 400, 1 minus 1.0008 to the exponent negative 1,040, close that bracket, and divide by 0.0008. And if you do this correctly, you end up with $282,338.58. So that's how much money he has to put in now to give himself a salary of $400 every week for 20 years. So remember, he's withdrawing $400 a week for 20 years. So let's see how much interest he earned by putting all this money into an account and then slowly withdrawing every week. So first of all, our answer from above, that's what he started with. Next, he withdrew $400 1,040 times. Remember, that's our N value, the number of weeks. So he withdrew a total of $416,000, and therefore the interest earned, or how much he made, is just the difference between $416,000 and how much he started with, $282,338.58. So not bad at all. In that 20-year time period, he also made $133,661. So he put in the $282,000, he slowly withdrew it, and whatever was left in the account made money, and during that 20-year time frame, he made an extra $133,000. So this is one type of present value calculation. You have money that sits in an account, and you slowly withdraw that money, but the rest that sits in the account is still making you interest. Example 2. Josh plans to buy a car. He can afford a monthly loan payment of $350. The dealer offers a loan at 3.6% per year compounded monthly for 5 years. How much can Josh afford? So again, this is a calculation for a loan. So we need our present value formula. And remember that present value equals R. 1 minus 1 plus I to the negative n, all divided by I. We have our regular payment of $350. We have our interest rate of 0.036, but remember we want to convert it to months, so we have to divide by 12, and that gives us 0.003. And then we have the number of payments. So it's 5 years, but we want to convert it to months, so we times by 12, and we end up with 60. Next, we're going to sub this into our formula. So present value equals 350, 1 minus 1.003 to the negative 60, all over 0.003. Using our calculators, we end up with $19,192.21. So this is how much Josh can afford. So if Josh buys a car for $19,192.21, how much interest will he pay after this loan is paid off? So let's go through the steps again. He paid $350 per month for 5 years, so that's 60 months. So that means he paid $21,000 for the loan. But remember that the car was worth $19,192.21. So he paid $21,000 for the loan, but the purchase price of the car was $19,192.21, which means he paid $1,807.79 in interest. So this is money that he gave to the bank because he didn't have enough money to buy the car all at once. Here are some questions for you to try.